Alright, so this is episode 2 of the electromagnetism series, and in this episode, like I said, we have explanation, summary, explanation, summary, explanation, summary. Okay, that's how it's gonna work. So this is a short video on the summary about everything we took here, okay? Right hand rule. The right hand rule, it is a rule to determine the direction of magnetic field around a current carrying wire, because we have stated that a wire that is carrying current has a magnetic field around it, but I don't know what is the direction of this magnetic field. Is it clockwise or anti-clockwise? To identify that, we use the right hand rule, okay? How to use it? We're going to take our right hand, close it into a thumbs up, okay? Thumbs up, perfect. Thumb points where? In the direction of the current. It could be up, it could be down, it could be left, it could be right. Either way, follow the exam instructions, follow the question. Thumb points in the direction of the current, okay? Depending on whether it is into the paper or out the paper. What does this mean? Let's come here. Into the paper is represented by X. They could say that the current, okay, is going out of the paper like this. Look, out the paper. So we will represent it by an O. If the current is going into the paper like this, we will represent it as an X, okay? So, thumb points in the direction of current, depending on whether it is into the paper or out of the paper. After you point the thumb in the direction of the current, okay, wherever your fingers are curling, this is the direction of the magnetic field. The side your fingers turn, circular direction, this is the direction of the magnetic field around the current, okay? We took two examples over here. In this example, the wire is going out to the paper, so current is going out, thumb is going up, so magnetic field is curling in this direction. So O, and magnetic field is anti-clockwise. In the opposite example, we took a paper where current is going into the paper, so current is going down, thumb with the current going down, magnetic field is clockwise, okay? Perfect. The short note we took in the previous video was simply that in both cases, okay, we always draw the magnetic field lines further apart, okay, as we are drawing them. For example, this is the magnetic field line, one, the second will be further apart, the second one will be further apart, and so on and so forth, because we know that the magnetic field lines do not maintain the same strength the whole time. They are getting weaker, like two magnets. Over here, magnetic field lines are very dense, so it is a very strong magnetic field. As I'm moving them away from each other, the magnetic field lines are becoming less dense. The magnetism or magnetic force between them is decreasing because the space between the lines is increasing. This is why whenever we are drawing these diagrams, we always make sure to make each loop further apart from each other, not the same distance. It's a very common mistake to show that the magnetic field is getting weaker, okay? It's very important to learn how to use it. Remember that thumb is always with the current, fingers are always with the direction of the magnetic field, X is into the paper, O is out of the paper. And yeah, in the next video is going to be episode 3, in which we are basically going to be starting the new idea or topic. This is just summary of the previous video, so I'll see you in that one.